Good morning, students. Let's start the fourth lecture of Module 2, that is pumps and actuators. Today we are going to cover the topic that is vane pumps. Okay, myself Viresh Kumar KS, working as assistant professor in Jain Institute of Technology. Let's start the class. Okay, vane pumps. As in the earlier class, we have studied regarding the gear pumps. In the gear pumps, we concentrated on the different types of gear pumps, that is external, internal, gear rotors, low pump. Like that, we have discussed in that what are the gear pumps. Now, somewhat the other types of pumps we are discussing in here is vane pumps. Vane pumps are having somewhat different constructions where we are going to find a veins, so that will help to pumping action. Okay, so the vane pumps are mainly classified into two types. One is unbalanced vane pump and balanced vane pump. So in the unbalanced vane pump, we have fixed displacement type of vane pumps, and another one type is pressure compensated variable displacement type. So like that we are having the two types in the unbalanced vane pump. Why we call it is unbalanced and balanced? Because so the unbalanced it is nothing but we are not going to have the balancing operation in here. So but in balanced vane pumps, so what we find, it will automatically get balanced, and it will useful in the pumping action. So unbalanced fixed displacement vane pumps. Okay, in the unbalanced we have the fixed displacement vane pumps. So that is the first type. You can see the diagram in here. So first we will see the diagram construction. This is the unbalanced vane pump. In that fixed displacement. Okay, why we call it as fixed displacement means we have the only fixed amount of fluid is going to be displaced in here. So there is no variation we can observe in this type of whatever the pump. So first is the constructions. So first we say in the center we can find a rotor block. The bigger circular block is seen in here. So it is a rotor block. Okay, which this block is consisting of a radial slots. Okay, so the radial slots is mainly for to provide the passage for the veins. This black colored whatever the thing which is shown in here is a vein. So these veins are free to reciprocate in this whatever the gaps, the vein slots which are provided here, and it can reciprocate with respect to the centrifugal force applied while the rotation of this whatever the rotor block. So this is the case in our cylinder block, which is covering this whatever the rotor block. And one more thing is we have this one line, circular line, which is presented here. It is called as a cam ring. So this is a cam ring. So the label is not done in here. So this is a cam ring. So whatever the this vanes, the rotor is going to rotate in this direction, and this it rotates, it will tends to reciprocate these vanes inside the slots, and because of the centrifugal force action. So as it rotates, this vanes are going to tends to move outward. In this portion, the volume is get increases. In this portion, what happens? The volume get increases because of this whatever the vane movement. It will slide over this whatever the cam ring. So when the this whatever the veins slide over this cam ring, it will make some volume increase. Means they will take away the air particles or anything which is present here, and it will make the vacuum, partial vacuum at here, and volume get increases. Because of that, the liquid is going to be come inside, or it will be sucked inside at this portion because of the partial vacuum. Next, this liquid is going to be transmitted. So you can see these veins are making a block like structure. So it is making one block of whatever the liquid particles is going to be taken away, and it will be transmitted it at this portion. So what happens? This liquid is going to be collected at here because of reduction of volume. You can see this rotor is eccentric to this whatever the cam ring. It is not at the center. It is having some eccentricity. So because of that eccentricity, the volume increasing and decreasing takes place in here. So in here the decrease of volume you can find in here also there is a lesser volume. At here it will be a greater volume. So like that the volume variation will result in partial vacuum, and because of that the liquid is going to be transmitted. As the liquid come to this portion, the liquid tends to experience lower volume, and because of that the liquid is going to be pushed out with a higher pressure. So like that this whatever the unbalanced fixed displacement vane pump works. You can see here the rotor contains a radial slots splined to drive shaft. So it is going to be splined to and it having the rotor slots. The rotor rotates inside the cambring. Each radial slot contains a vane. So you can say this radial slots which are present at here, it is contains a vane which is free to slide in or out of the slot due to centrifugal force. Due to centrifugal force, it is going to move in or out. The cambering axis is offset to the drive. Cambering offset is offset to the drive shaft axis. When the rotor rotates, the centrifugal force pushes the vanes out against the surface of the cambering. The vanes divide the space between the rotor and the cambering into a series of small chambers. This whatever the series of small chambers is going to be divided by these vanes, because of that liquid is going to be transmitted. Okay. So during the first half of the rotor, the first half rotation is till here. You can see the one line at the left side. During the first half of the rotor rotation, the volume of these chambers increases. Volume is going to be increases from here to here, thereby causing the reduction of pressure. So as the volume increases, pressure is going to decrease here. This is the suction process which causes the fluid to flow through the inlet port. Okay, as the inlet port opens, it collects that water of the liquid because of the partial vacuum. During the second half of the rotor, the cambring pushes the vanes back into the slot and the trapped volume is reduced. So if this is the right side, this is the second half. What happens? The cambering is going to push this vanes inside. Because of that, volume is going to get reduced, and that the liquid experience the higher pressure and it will be pushed out. Okay. Next, this positively ejects the trapped fluid through the outlet port. Okay. The delivery rate of the pump depends on the eccentricity of the rotor with respect to the cambering. So delivery port you can be experienced by with respect to the whatever the eccentricity provided for this, whatever the rotor and the cambering, which will leads to the delivery can be varied, or it can be achieved with a limited range. You can see the operation, working operation in here. This is the rotor which is rotating inside here, which is having the circular slots, radial slots. So in that radial slot we can see you can see a small cambering in here. This is a line which is shown in here. This is a cambering. These vanes which are reciprocating in and out, and it will be guided through this cambering as the centrifugal force is going to be applied. Okay, because of that the first half the liquid is going to be having a lower pressure, and second half it is having a higher pressure, and it will be transmitted it here. So like that this will be working. So next, the unbalanced pressure compensated variable displacement vane pump. Okay, so this is unbalanced pressure compensated. So what happens, this whatever the cam this whatever the pumps which experience the pressure. Okay, so while pumping action takes place, if there is some not requirement of fluid in the next stage. Okay, for example, if you have some still operation, or if you have the operation which should not lead a higher pressure, so in that area what happens, the pump experience the higher resistance. Okay, higher resistance of fluid flow that builds the pressure inside the pump. So that pressure leads to some effect on this water the pump, and it will lead to the whatever the diminishing of pump, or it is destruction of pump may takes place. So to avoid that we require that pressure compensation. Okay, so as the pressure okay, pressure compensation is required, because if you experience higher pressure it should be reduced. Okay, so that may not affect the pump action. Okay, but in here what happens, if you have the pressure compensation, you can protect the whatever the pump, and it can be operate for the longer term. So that is the one of the advantage. So we will see the construction first. Okay, similar in the earlier we have seen, one is the rotor which is present at the center, which is having the radial slots. As in the earlier we have seen, it is having the radial slot. In the radial slot we find the vanes, the dark color, whatever the reciprocant elements are called as vanes. This will reciprocate with respect to the guidance of the camber. This is the camber. Okay, this is the camber which is provided here. This is the camber. So okay, this as the rotor rotates, the centrifugal action will tends to move this whatever the vanes in and out to make the reciprocation, and it will be guided through the cambering. So what happens, the cambering is connected to the compensation spring, compensator spring, and it is also connected at the another end. It will be connected to the compensator piston. Okay, compensator piston. So outlet pressure. So what happens, you can see here, as the this whatever the eccentricity is the main cause, since the maximum eccentricity means the maximum output we can expect from the pump. If the eccentricity is less, eccentricity is nil or less, what happens, the pumping action not take place. Why? Because there is no pressure variation you can experience, there is no partial vacuum is going to be considered. So because of that, there is no pumping action takes place in this whatever the pumps. So what happens, we can vary that eccentricity by this mechanism. What happens, as the pressure increases, assume this is the inlet. In here, in this portion the inlet is causing, at this portion the outlet is there. So what happens, the outlet is having the higher pressure, so it is more than the pressure which is not beared by this whatever the pump. So what happens, the pressure is going to be increased at here, so it should be relaxed. So one of the pipe is going to connected to this whatever the outlet pressure. So when it is connected to this, the liquid comes here and it will pushes this compensator piston. Liquid comes here and pushes the compensator piston. As it pushes the compensator piston, the cam move to this, move to the center of this whatever the center of this cambering is going to move towards the center of the rotor. Okay, rotor disc. So what happens, as the cambering center move towards the rotor disc center, it will tends to make the concentric circle phenomena. So because of that concentric phenomena, there is no pressure difference can be experienced, and it will not pump the liquid. So that may happen. As the pressure decreases, the pressure is high at here. As the pressure decreases, it will take away the liquid from here. The piston is going to be pushed back because of the action of the spring. As the spring is going to work, the cambering move towards again to the whatever the eccentric point, and it will operate as required in the pumping action. So like that it is going to be there. You can see here, this is the maximum position, the zero deadhead position. Okay, so what happens, if this cambering circle come to this point, what happens, that whatever the liquid can be, the liquid, the center it is going to come to this point, what happens, it have no displacement of a liquid. If it is at this eccentricity, we will experience the maximum output. So this is the symbol of this whatever the compensator variable displacement vane pump. Okay, we'll see that the symbols later. Okay, we'll have the same explanation in here. Variable displacement feature can be brought into the vane pump by varying the eccentricity between the rotor and the cambering. We are mainly concentrating on the eccentricity variation. Here in this pump, the stator ring is held against a spring-loaded piston. The system pressure acts directly through the hydraulic piston on the right side. This forces the cam ring against the spring-loaded piston on the left side. If the discharge pressure is larger enough, it overcomes the compensated spring force and shifts the cambering to the left. This reduces the eccentricity and decreases the flow. If the pressure continues to increase, there is no eccentricity and pump flow becomes zero. Okay, the same thing they are saying. As the pressure, the discharge pressure is more, the eccentricity is going to be lesser. The piston makes the eccentricity to a lesser point. Because of that, flow is going to be reduced and the pressure going to be maintained. If the pressure is going to be reduced, the discharge pressure is less, then again the eccentricity is going to be maintained. You can see the working. Okay, the similar in here. This is the piston, this is the spring. So what happens? First, initially it will be in this portion. Okay, so this is the camering, this is the rotor, and the vanes which are yellow in color, the slots, radial slots are present. So what happens as the inlet pressure increases, this will be the discharge pressure is increased, then this will be made to be concentric, then the flow is going to be reduced and the pressure can be maintained. Okay, so this is all about the unbalanced vane pump. Next we move on to the balanced vane pumps. Okay, balanced vane pumps, you can see balancing is nothing but there is no eccentricity is going to be finded in this type of whatever the balanced vane pumps. In earlier we have the unbalanced vane pumps where eccentricity should be maintained for the discharge. In here we are not maintaining any eccentricity. Just by changing the design we have the balanced vane pump. First see the construction in here. This is the balanced vane pump. Centrally you can find the this whatever the rotor block which is hang the radial slots. Okay, and in each radial slot we can find one vane which is darker in color in here. Okay, and you can see the camber is oval in shape. Okay, the camber is not circular, it is oval in shape. You can see this is the camber, it is not circular, it is oval in shape. And you can also find there are two inlets. Okay, there are two inlets and there are two outlets. Okay, there are two outlets and there are two inlets. Let's see. The rotor and the casing are on the same center line now. That is called as balanced vane pump. The rotor and the casing both are in a same center. The vanes are provided in the slot of the rotor. There are two inlet and outlet chambers around the elliptical cambering surface. So the cambering is an elliptical shape. So there are two inlet and outlet going to be provided. The inlet and outlet chambers are positioned diagonally opposite to each other. Okay, their inlet and outlet are opposite. It is provided in the diagonal manner. Okay, the cambering is elliptical in shape so that the vane stroke twice per revolution of the pump shaft. Because of this elliptical shape of a cambering, the twice stroke at the simultaneous time, the inlet and outlet stroke can be experienced in this type of whatever the vane pumps. Thus, the volume increases and the decreases at the inlet and outlet chambers also occurs the twice per revolution. Okay, what happens? You can at a one revolution of this rotor block, what happens? At this portion, the volume gets increases. The volume increases at this portion. Similarly, in here also the volume get increases at this portion. So, because of that volume increase, the vacuum is going to be provided at these both ends. In here also we will find the vacuum and here also we will find the vacuum. So because of that, the simultaneously the inlet is going to be the liquid is going to be sucked inside in here. Then outlet at the simultaneous position, this volume reduction is also going to take place at this position. At this position also, as the rotor rotates, the volume gets reduces and the liquid experience the higher pressure. In here also, it will experience the higher pressure and the liquid is going to be pushed outside. So like that, in fact the inlet and outlet ports are connected to the okay, twice per revolution. Both are the suction and discharge going to be acted twice at each cycle of this whatever the balanced vane pump. The inlet and outlet ports are connected to the common inlet and outlet within the pump housing. This inlet and inlets are connected to a common point and outlets are also connected to the common point in the housing of the pump. In operation, due to the elliptical shape of the camering, the oil suction at the inlet and the pumping at the outlet occurs simultaneously. This situation results in equal pressure on the opposite side of the pump shaft and the net force acting on the bearing will be zero. Okay, thus it is termed the balanced vane pump. Okay, what happens? This situation results in equal pressure on the opposite side. Equal size is going to be experienced. pump shaft, and the net force acting on the bearing will be 0. So as you see, inlet is also at the diagonal position, and the outlet is also at a diagonal position. Because of that, the both ends will experience the same amount of pressure, and it will not affect the bearing of that whatever the rotor. Okay, in other pumps it will be having the effect on the bearings. So in here there is no that so that is, it is called as a balanced vane pump. I can see the operation. Okay, balanced vane pump, you can see the operation in here. So this is the rotor rotating inside this sort of the housing, and you can see the elliptical shape of the camering. This is the elliptical shape, and the whatever the black colored is a vane which is reciprocating inside this radial slots. This is the input. The blue color is going to be considered as a inlets which are diagonally opposite. Okay, and this is the outlet, red colored, which is also diagonally opposite. Outlet ports are provided at here. Okay, you can see as this rotor rotates at a simultaneous time, suction in this portion suction takes place, and in here also suction takes place because of the increase of volume, and the partial vacuum is created, and these two portions the volume going to get decreases, and the liquid is going to be pressurized outside to flow to the next point. So like that operation is going to take place in the balanced vane pump. Okay, we will see the advantages of vane pumps. Vane pumps are self-priming. We know the meaning of self-priming. It is nothing but it is having the ability to remove the air particles inside that whatever the pump housing. Robust, it is having the robust structure, and supply constant delivery at a given speed. Why we call this it is robust? Because it is having the pressure, equal pressures at inlet and outlet. It results in no pressure or no loading on the bearings, so it can work for the longer term. So that's why it is called as a robust construction. Supply constant delivery, so inlet and outlet are constantly occurring, so because of that constant delivery is going to be expected. They provide uniform discharge with a negligible pulsation. In here there is no pulsation can be experienced because continuous veins are coming, veins are pushing that water liquid to the next stage, so the pulsation is going to be lesser in here. Okay, the vein numbers are also higher, so that's why pulsation is going to be reduces. Their veins are self compensating for wear, and veins can be replaced easily. So veins are self compensating for wear. What happens as the wearing takes place in the inside that vein, it will be self compensated by this whatever the centrifugal force, and it can easily remove that whatever the replace that veins. These pumps do not require check valves. There is no requirement of check valves. As in the piston pumps, we require the check valves for the inlet and outlet strokes. But in here, there is no requirement. They are light in weight and compact. It is one of the advantage. They can handle liquids containing vapors and gases. Volumetric and overall efficiency are high compared to the other types of pumps. Discharge is less sensitive to changes in viscosity and pressure variation. So discharge is not that much sensitive as compared to the other type of pump. So we will see the disadvantages. Relief valves are required to protect the pump in case of sudden closure of delivery. So what happens? Continuously flow is taking place in the vane pumps. It should be relieved if there is no requirement or the pressure builds up in the next stage. So relief valves are a major requirement in here that will relieve the pressure of the whatever the pump, and it will maintain the. It will not disturb the whatever the overall operation of pump. Okay, they are not suitable for abrasive liquids. Obviously abrasive liquids can't be pumped in here. They require good seals. Good seals are because sealing may increase the efficiency of whatever the liquid, so we require the good sealing. They require good filtration system, and foreign particles can be severely damages the pump. Okay, it should require the filtration because it will leads to some improper operation or wearing phenomena in this whatever the pump may takes place because of the contaminants. So applications. These pumps have various applications for pumping of the following fluids. So aerosol and propellant fluids can be pumped by using this whatever the vane pumps, aviation services, fuel transfer, DCing. Okay, so like that operation is going to be takes place. Auto industry, fuels, lobes, refrigeration, coolants. This can be pumped in here, and bulk transformation of LPG and NH3, LPG cylinder filling, and alcohols industries can use this type of pumps. Refrigeration, freons, and ammonia for pumping this action can be used, and solvents. So these are the fluids can be pumped by using the vane pumps. Okay, thank you, students. I hope you have got a lot of information regarding the vane pumps. If you have any doubts regarding the this vane pumps, you can ask you can comment, or you can ask through my contacts. Okay, thank you for watching.